Alright, this is topic 20, the equation of a tangent line. So we're going to talk about a couple of things that should be familiar and one thing that's very different. Alright, so to write the equation of a tangent line with this function and that point, we're going to use the exact same formula that we used on lesson 18. So remember that the formula was this. I'm going to write it up here. The derivative formula at a point C is equal to the limit as x approaches c of f of x minus f of c over x minus c. Alright, so don't forget that that's the formula I'm going to be using for this. Now notice that on here you don't have c is equal to, but that's okay because that c value is just an x value. So this will be your c value. Okay? So don't forget. So the first thing we got to do though is we need to find out what f of c is. In this case I need to find out what f of 3 is. So when I plug in a 3 back into here, I get 1 minus 9. So that's going to give me a negative 8. Alright, so I have a point on the graph, so I'm going to write this like this. I have a point on the graph that's 3, negative 8. Alright, so let's make sure we understand what we're looking for here. We're finding the equation of the tangent line with this equation right here. So I'm going to graph this here in just a second, so hopefully you understand. Alright, so to find the equation of a line, remember the two things that we need is we need a slope and we need a point. We already have the point, so now we need the slope. And to find the slope, I need to use the derivative. So the derivative at 3 is equal to the limit as x approaches 3 of 1 minus x squared. Notice that this is f of x. This right here is f of x. Okay? And f of c is going to be negative 8. So I'm going to have a minus a negative 8, which is going to make this a positive 8. Right? So now I'm skipping some steps. I'm not actually writing a lot of stuff down like I did on lesson 18, but hopefully you can follow. Right? Now over x minus c. X is just x, and c in this case is 3. Okay, now we're going to add like terms before we try to even plug in the limit. So I have this. So I have, let's see. Okay, I'll write it in 2 steps. I have negative x squared plus 9 over x minus 3. Right now, notice that I should always try to plug in the limit. If I plug in the limit over here in the denominator, it'll give me a 0 in the denominator. So therefore, I should try to factor. All right. So before I try to factor them, I'm going to rewrite this like this. I'm going to rewrite this as the limit, and I know you kind of have to write that limit. All right. So I'm going to factor out a negative out of here. So if I factor a negative, I would have x squared minus 9, like that, over x minus 3. Right, so the difficulty in the algebra is what's going up here, right? So the difficulty is going up for algebra, but other than that, the calculus is the same. So now, hopefully you notice that this is a difference of squares. So again, the derivative at 3 is equal to the limit as x approaches 3 of negative x plus 3, x minus 3. Right, please notice how that negative stays outside, and I have x minus 3 here. Alright, so this is going to cancel these. Alright, and then now I can plug in my limit. So I'm going to plug in that 3 into here. Notice that that's going to give me a 6 here, but with a negative. So this is going to be equal to negative 6. Alright, so to rewrite this, finally we have the slope of the tangent line at 3 would be equal to negative 6. So I'm going to write this here. This is the slope of the tangent line. So this is basically review from 18. This is just a little bit more difficult. All right, so to find the equation of a line, we're going to use the point slope formula. So I'm going to write the point slope formula here for you again. Point slope formula. Okay. So remember, this would be y minus y sub 1 is equal to the slope times x minus x sub 1. Like that. Where x1 and y1 is that point right here. So we're going to have y plus 8. Notice that we have a minus, a negative 8, makes it a positive 8. is equal to the slope. The slope was negative 6. And we have x minus 3, right? Notice that that's the x value here. All right. Now, this will be your answer. If you want to circle that, I will take it. No big deal. That's fine, okay? Now, I'm going to simplify it a little bit further, though, so I can show you this on the calculator. So this would be y is equal to, let's see, that would make positive 18. So this is negative 6x plus 10. All right, so yes, I simplify that, so that's what you get. So the only reason I'm doing this is that I want you to see that if, let me clear this off. If I go here and I type in my original equation, which is y minus x squared, y minus x squared, and I type in this line, this is, remember, this is the equation of the tangent line at x is equal to 3. So this will be negative 6x plus 10. Right now when I graph this, I should have a parabola and then I should have a tangent line that only touches, in this case, 4. Alright, so notice that right here would be 1, 2, 3, 4, so the tangent line is somewhere over here. Okay, so they're sharing a point. Notice that this tangent line is not crossing through the function or anything like that, so that I know I did this right. Alright, so remember what we just found is this line. And that's it. That's all we found. All right. Now moving on to the next one. So next one is, again, same formula. So we're going to use the same formula. We're going to find the equation of the tangent line. So again, we need a slope and we need a point. Notice that on this one, they already give us the point. So we don't have to do anything else. All right. So where this is C, if you will. All right. This is C and this is f of C. All right, that's what we have there. All right. So we're going to find the slope. So we can put that on the equation of the tangent line. So we have the limit as x approaches 1, right, notice that 1 came from here, of f of x. F of x in this case is 2 over x, minus f of c, and f of c is 2, over x minus c, and c is 1. Alright, so that may look kind of ugly to you, but the first thing I would do if I have something like this, notice again, if you try to plug in the limit, you're going to have a 0 in the denominator. That's not going to work. So I have to do something with this. Alright, so what I'm going to do here is I'm going to find a common denominator up here. Alright, so I'm going to multiply top and bottom here by x. Alright, so that's what's going to happen. So I have the derivative at 1 is equal to the limit as x approaches 1 of 2 minus 2x over x, and that's going to be divided by x minus 1. Alright, so notice that I just kind of rewrote this horizontally. Alright, so after that, what I'm going to do is I'm going to go ahead and keep change flip. So I have 2 minus 2x over x times 1 over x minus 1. Now at that point you might be thinking, well, what else can I do? Hopefully you recognize that you have a common factor here, and you can factor a 2 out. Now not only am I going to factor a 2 out, but I notice if I factor a 2 out, that's going to give me 1 minus x, which I cannot cancel with this. But if I factor out a negative 2, so again, I'm going to factor a negative 2, now that's going to give me negative 1 plus x, but I'm going to go ahead and write it as x minus 1. Right, and if you're doing your own work here and you're like, well, I don't know how you got here. Well, factor a negative 2 and see how I got here, right? So if you're thinking about missing a step, yes, I probably did skip a step. Figure that out. All right. So this is going to be x, and this is going to be 1 over x minus 1. Now, this and this will cancel, all right? So finally, I can go over here and say that the slope of the tangent line at 1 is going to be equal to the limit as x goes to 1 of, let's see, negative 2 over x. Interesting. Didn't see that coming. All right, so all I have to do is plug in a 1 there, and when I do, I get a -2. All right, so f of -1 is equal to 2, okay? And children, hold on, I'm recording. No. I know we're meeting here, right?
Yeah, but are we going to meet just in that conference?
Yeah, let's just meet in the conference.
Okay, I'll go offline from later.
Okay, thanks. All right, sorry about that. So remember that this right here, this is the slope. This is the slope of the tangent line at 1. All right, so now we're gonna just do the point slope formula that I showed you above. So I have y minus 2. Remember, this is the y. It's equal to the slope. Oh my gosh.
Can someone from the custodial staff please call the front office? Someone from custodial, please call the front office.
Okay, so here's your equation of the line. All right, so you can leave it like that. So again, this is just review, just the difficulty of the algebra is a little bit higher. All right, so let's go to the next part. So we're matching the function f of x to the correct derivative, all right? So we're trying to figure out if this is f of x, which one of these two is the derivative? Now, we have already talked about this a little bit with everybody, but remember, if this is of degree 2, right, this is a quadratic degree 2, meaning it could have maximum 2 roots, then the derivative will have a degree 1. Okay, we'll have a degree 1. So it always will, this right here will always have 1 degree less than the original. All right, so we know that at least we have the right idea here. And also, this is a positive parabola. So the derivative should be a positive. All right, so which one of these have a positive here? This is a positive slope, this is a negative. So without doing much work, I know that has to be the correct graph for the derivative. All right, now I'm going to do something here real fast, just because this is not too difficult, but once you go to the back, it gets more difficult. So I want to make sure you know what I'm doing here. So sometimes when we have a graph that's difficult to figure out, I'm going to do some sign analysis here. All right, so what I'm going to try to figure out, this is a very important point right here, all right, where the slope is 0. So notice that what I'm going to do here is that this function is decreasing. All right, so this function is decreasing all the way until I get to that point. Now at that point, that's x is equal to -1. All right, so I'm going to put a -1 here. And then after I go past that point, I'm increasing. So from here to here, I'm decreasing, then 0, right? Meaning I'm not decreasing or increasing. But after I get past this point, then I'm increasing. Okay? Now the derivative function should look very similar to that. All right, if I'm decreasing like this, then that means my slope, see all my slopes here, if I were to pick any point on this side right here, all the slopes will be negative. So I'm just going to put a negative here. And the slope right here is 0, so therefore I'm going to have a point right there. And then after I get past that point, all my slopes here will be positive. So I know that my graph needs to look like this, right? Where you're basically increasing, you have a negative. Remember, all these points basically means that you have a negative. All these points on this line represent the negative slopes on this one of the tangent lines. And all these points above the x-axis represent all the positive slopes. Okay, notice that right here, that's your -1. That's where you cross the x-axis. Right here at -1, the slope is 0. All right, so I'm going to go to the back now. All right, in the back, this is more difficult. Now, this above is the graph of the derivative. All right, so all of this right here is the graph of the derivative, and you are not sure what the graph of the original function's like. So the first thing it's asking us, okay, on what intervals is the function increasing? All right, now when they talk about the function, let's see. When they talk about the function, they're talking about f of x. All right, and make sure you understand that this is f prime of x. So they're not asking you about this. They're asking you about the graph you can't see. All right, so to do this without much work, what you need to do is to realize that if you're above this line right here, the x-axis in this point, that would be your zero slope. Okay? And everything above that would represent a positive slope on the tangent line. So if you have all positive slopes, that means you're increasing. Right? So you're increasing between here and here. Everything above the x-axis is increasing because you have a positive slope up here. All of these represent a positive slope on f of x. So this would be negative 8, comma 12. Notice that I have an open interval because negative 8 and 12 are actually 0. All right, so they're neither increasing nor decreasing. Now it says, in which intervals are the functions decreasing? Well, it's the same idea. Everything below the x-axis represents every point on here represents a negative slope on f of x. Okay, so that represents a negative slope on f of x. And if you have a negative slope on the tangent lines, that means you're decreasing. So between negative infinity and 8, so between negative infinity and negative 8, and between 12 and positive infinity, so if you have 12 and positive infinity, see everything below here, right? Everything below here is going to be between 12 and positive infinity. Okay. So now the question then becomes, where does the function, and remember, we are not talking about this function up here. This is the derivative. Now they're asking us, where does f of x have a maximum? All right, so you have to think about it like this. All of these right here represent a negative slope, and all of these up here, all of this represents a positive slope. So if you're decreasing here, that would be a decreasing function, and then you have 0, and then you have positive, or increasing. So basically what that would look like, and I'm going to cheat a little bit here. I'm going to say that on this side, for example, you would have something that would look like this. If you're decreasing, and then 0, and then increasing. So this one's actually a minimum. But this one over here, you're going from increasing 0 to decreasing. So if you have increasing, and then 0, and then decreasing, then you have a maximum here. Okay? So right here, where's your maximum located? Well, that's located at x is equal to 12. All right, and do you have a minimum? Well, the minimum, like we already talked about, it has to be at negative 8. It says, what degree will the function have? So this is backwards. Remember, this is the graph of the derivative. So if the graph of the derivative has degree 2, the graph of the original will have a degree that's 1 higher than that. So the degree of the original has to be a cubic, which is degree 3. All right. Now they're asking us to sketch the function below, and this is all you need to sketch. You need to figure out where, see, this is f prime of x, so actually we are talking about this. Right, so notice that the key points that I need is this one and that one. I don't care about that point, at least not at this point in this class. I need to know what that point is and that point is. So I'm going to put that over here. So we have negative 8 and we have 12. All right, so this is the graph of the derivative, right? What happens to the left of negative 8? Well, those are negative slopes, so I'm going to put a negative. What happens between negative 8 and 12? Well, I'm above the x-axis, so that means I'm increasing, or I have a positive slope. I have positive slopes up there. And when you go past 12, then you have negative slopes. Every point on here represents a negative slope. So see, you have negative slopes, positive slope, negative slopes. Well, that translates into here, and to having decreasing, increasing, and decreasing. All right, so notice that these kind of match, right? I just wrote out something different. So to sketch the function below, I notice that I'm going to put this negative 8 here, and I have a 12. Now, do not be deceived. Remember that negative 8 and 12, we already talked about it. Negative 8, I have a minimum. And on 12, I have a maximum. So you have to start, look at it. You start decreasing. Now, whether you start here or here, it doesn't matter. What matters is that you stop right here. You need to stop decreasing at that point, because at that point you have a slope of 0. And then between -8 and 12, you're increasing. So you better go up. Right, up, 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 until you hit 12. Right, because 12, you also have a 0 slope. And then after that, you're decreasing. What's the degree of this? 1, 2, 3. That's degree 3. All right, this is by far the most difficult thing you have done so far, just conceptually. I will not be here for some of your classes, so make sure if you don't understand, have your questions ready for me when I get back. All right, I hope this helps. I'll be back tomorrow for some of you.